design is at the center of the product development process. So they're deeply tied to the user and what the user requirements are, and kind of thinking about how this product would be used and interacted with. But they're also responsible for kind of the system integration of everything and balancing all of the trade-offs to actually meet those user requirements. So that could be like, technical requirements, performance, cost, weight, reliability, human factors. And so the product design engineer or product design group needs to not only be able to zoom out and think about the user kind of in a 10,000 foot view during some stages, but they also need to be able to dive hyper into the details to be able to balance all of these trade-offs. And they almost need to become experts in all of these different fields so that they can balance all those trade-offs to make sure that the product doesn't get watered down and there isn't some trade-off that doesn't make sense and it actually becomes compelling for somebody to buy.
Product is a final deliverables, but it feels like a very much a cross-functional collaboration, cross-functional teamwork, as well as leadership to make things happen.
Absolutely. Yeah. I mean, I think it really is, the product design team is interfacing constantly with all of these different other teams and really trying to understand their requirements. And it's one of those things where, I think we've all seen products where you can kind of tell that something was driven more from a technical requirement than from a user requirement. And so that's where I think it's really important to have a strong PD team that can help balance that out and always think about the user, but be kind of driving all of these other functions to get in line.
So what takes to be a good product design?
I think you kind of have to have almost two minds. You have to have one mind that you're able to kind of like in the early phases of product development and product design, you need to be able to think really creatively without being bogged down by the technical constraints. This helps kind of put the user first, think about what feature sets are really important and how you might achieve them, but not get bogged down too much. And then at the later stages, as you're getting more into the detailed design, you kind of have to flip a switch and dive hyper into the details and almost become a mini expert in electrical engineering, mechanical engineering, antenna engineering, human factors, whatever it might be, so that you can kind of push and pull each one of those teams to achieve the stated goal. And so I think good PD really are able to kind of make that switch, but it really is important that you're able to kind of balance these trade-offs, get hyper into the details, and see it all the way through into production. Kind of the basics of product development is kind of this overly simplified 3-phase process, which is, starting with the marketing requirements document, which is really kind of the why and the who of what you're building. The PRD, the product requirements document, which is kind of the what, and the ERD, which is the how. And I think while product design doesn't necessarily need to be responsible for every single one of these things, they are intimately involved through the entire process. And so the MRD is things like, who is your customer? How big is this opportunity? What's your kind of product market fit, your value proposition that you're bringing to the table? It really doesn't get involved at all in like, what is the incarnation of this product? It's just like, where do we want to go and who are we building this for? And then I think the product design team really helps translate that into a concrete PRD, which is kind of the what of what you're building. It's kind of the feature set. How are you going to achieve these kind of marketing goals? What's the behavior and functionality of the device that you're building? It may even include user stories about how a user might interact with this. They really shouldn't have any technical specs. And then PD also helps kind of translate that even further into the engineering requirements. And this is the how. Exactly how are you going to achieve those things? What are the specific technical details that are going to get you the features and functionality to meet all of these specs? And this is, like I said, an overly simplified way of viewing it, but most companies have, most successful companies are able to kind of target these things. It may not be perfectly linear, but they at least know these 3 elements. And I've seen a lot of companies start with like a marketing idea and go straight to an ERD without even proving to themselves why a particular feature should exist and if it actually is the right feature for the customer, not even proving that out. And I've seen it go the opposite way too, where it's like focusing only on the incarnation of this product, and we're going to have this exact chipset, we're going to have this, without really understanding why are you building this, who is it for, and what specific feature set does it need to have. Because without understanding all of that, all of those trade-offs that I was just showing, it's really hard to make those trade-offs because you don't actually know which one's more important. And the hardest thing about being a product designer is figuring out like which things are constraints and which aren't. Otherwise, it's like an unsolvable problem. And so I think these are kind of like, key elements to overall product development, but also good product design.
I love it. The simple version, I think that resonated a lot, right? First of all, the two mindset, the shift from early stage to late stage, that's wonderful way to put it. And then the three, requirement document, right? MRD, the PRD, the ERD. It's kind of the way you put it, like who, what, and how. I think, I couldn't find a better way to say it. So
I think it helps not only know what you are trying to build, but just as importantly, what you're not trying to build. And that can be just as important.
Yeah. So students in this class learn to develop startup ideas within a quarter of time. And at the final presentation, each team will compete for awards. So that's the fun part, right? But including a product design and concept, of course, product is a general term. It could be a software, it could be hardware, it could be a service, right? And then since you talk about early stage, late stage, so could you walk us through the product development lifecycle?
Sure. Yeah, I think every company does it slightly different. I probably have a slight bent towards kind of the consumer electronics product development cycle, and obviously software and whatnot, similar but slightly different. But at its core, pretty much all of these processes are a series of iterations of designing, building, and testing. And these are starting at the early concept phases can be very, very quick, like a half a day. You design something, you 3D print it, and you test it. But towards the latter stages of product development, they can get really, really long, where you're building many units that can be 3, 4, 5 months. So kind of going from left to right, it starts with like the planning process. And really the exit out of this is really a concrete MRD, like I was talking about. The next step is kind of the concept design. And a lot of times it takes a lot of concepts, a lot of prototypes to even challenge the assumptions that you have around the feature set. And the output of this whole phase really should be kind of a concrete product requirements document. And I think this is probably the area that companies struggle with the most. And it also is understandable because it's the most speculative. There's so many things to the right of this, when you're starting to invest in tooling and getting closer to mass production, that like real fundamental mismatches and assumptions early on really can totally derail the rest of your product development. And so I think this is the most kind of delicate phase of the product development cycle. And some companies do it really well. And some companies, oftentimes even skip it and don't challenge the assumptions. So, the next phase after that is kind of detailed design, going into prototyping. Not to say the concept design doesn't have prototyping, it very much does, but they're really typically targeted around certain features and maybe user testing and customer feedback and things like that. But the detailed design phase really is more about proving out how you're going to achieve the PRD. And this could be typically with rapid prototype parts. This phase, you're getting out of the crappy prototypes and you're trying to get into a little bit more high fidelity. And kind of the goal of exiting this phase is a real concrete idea of kind of the architecture of your product. And then from there, it continues to be design, build, test, but these phases get much longer and you focus on how do I get this closer to representative for mass production? How do I maybe build 50 or 100 or 1,000? And the processes might look totally different. And so you'll go into validation phases here. And then for some companies that are building really, really high volume production, they'll have a production validation phase, which is just like your product has a design phase to it, so does the manufacturing process too. It's its own product, really. And now you look at Apple, I think that the manufacturing design group is doing incredible things with crazy automation to get iPhones to the state at which they are. So a lot of that is kind of ironed out at this kind of production validation phase as well, and then into mass production. And then you have to really monitor what's going on in mass production. What kind of failures are you seeing? What's the user reaction? And ensuring that you have a really quick feedback loop to try to address some of those things. But again, if you don't have like the core fundamentals early on in the process about defining the product, it doesn't really matter what you're doing towards the latter end. And it usually means that there's going to be some major change at the end that's going to be really costly or problematic. So that's why I'm kind of like harping on kind of this early stage PRD process is so crucial to the success of kind of your product development.
So I'd like to zoom in a little bit in terms of how do you actually validate the design and apply the learnings. Could you actually give us some examples?
Yeah, so I can give you some examples from Shaper. I mean, when we were working on Origin, during the PRD stages, we were like, okay, how is this product not only going to function, but how is it going to be used in real life? And that was really important for us to define that early on. We didn't want it to be like some sensitive robot that people use in a workshop and that breaks all the time. And so we really needed to look at what kind of environments that this would live in. And from there, since that was all defined really early on, we were able to construct pretty detailed testing of how to put Origin through its paces. So one example is us doing dust ingress testing. We constructed our own dust chambers, we made them, and we basically ran this device that has precision electronics and CNC components in it, and basically just tried to blast it with as much dust as we could and see how is this thing going to fail. And we had to make a couple different iterations there to seal it better or to kind of protect the electronics in different ways. And there was a lot of design changes and things like that that went into that to get it to a point that we could stand behind it and say, hey, this is a really reliable thing, and we have confidence in moving into the next stage. And another example is this video here on the right, which is making sure that not only do we have to think about how it's used on a day-to-day, we also have to think about how it's transported, how it's shipped, and how it gets returned and to us, in the case of a problem. And so we ship our device in a outer packaging like this. And so we'll do drop testing, and we will ensure that nothing gets damaged. We have precision cameras on this device. So if anything gets moved, our calibrations can be off. So we had to go through a lot of iterations to kind of look at how this would be used in the real world and make sure we can put it through its paces and it would be okay. And that was really like a big aspect for us during that kind of engineering validation phase.
So now on the screen that I see a piano.
Yeah.
Special about that?
Yeah. So we did our best effort at all of these requirements and getting them all dialed. But one thing we wanted to do was be able to use Origin in a localized small features, but also like really large cuts and large features. And so, but we never really anticipated how this product would be used in every single scenario. And so it wasn't until we started actually building the device that we started to see specific applications that were kind of unexpected for us. And this is an example of one where we had a customer that was really interested in doing an inlay in their floor. So all the music notes that are in the floor are actually a different material. It's not painted on there. It's actually, I believe it's walnut. So it's actually a separate piece of wood that's inlaid into the floor. And we had designed the device to be used on really large work pieces, but we had never envisioned it like this. And so kind of this is an example of like being attuned to your customer, doing your best to kind of enable these kind of use cases, but also like we took this feedback and realized, okay, actually, you know what? Flooring installation is actually really interesting for us. And there's actually no other tool that I know of that can do this type of work. Typically, you'd have to do an inlay in the floor like this by hand with a template. You'd have to make a bunch of templates and do it all by hand or chisel it out. And so it was just a good example of an unexpected user journey that we were able to absorb this prior to going to production just by having close contact with our customers, potential customers, and having quick feedback loop to see how we can integrate this type of feedback into our product development cycle.
That's very interesting example. So throughout my professional career, I loved working with product designers. Besides creativity and technical depth, I'm always amazed by designers' ability to tell stories. So things you have talked about, successful examples, could you also share an example that didn't work? And what do you learn from it?
Well, I don't want to bag on Google Glass too much because I think there were some really good things, but I do think that clearly it wasn't the success that we were hoping for. So if I were to pick an example, it'd probably be related to some of the things that we learned with Google Glass. And I think that the vision for head-worn devices and AR glasses from a marketing standpoint is still really valid, and it makes a lot of sense. Like technology, that transparent technology, technology that's not in your way, seeing the world not through a screen, I think is compelling. And I think that's still really valid. I think what kind of happened here was, if you think about the MRD, PRD, ERD, like we had a really good marketing vision, but I think we too quickly went towards the specific incarnation of this project. And we went straight to the engineering specs and what kind of optics it would look like, what kind of optics it would have, without really like challenging kind of the feature set and what the real features should be. And I think you're starting to see a lot of other companies like Facebook releasing the co-development with Ray-Ban. They're starting small. They're starting with just cameras without kind of burdening the user with some kind of big, bulky optics. And I think there's a lot of rationale to that. And you have to kind of earn the right to be worn on someone's face all day. And so, I do think that the time is going to come where there is a set of AR glasses that are pretty much the exact same as regular glasses, but it's going to take some time to develop those technologies. And so I think Glass didn't succeed in that because I feel like we probably didn't have a firm handle on the feature set and why it should be that way, and too quickly jumped to the engineering specifications. And we kind of saw that as a result, kind of the lifestyle product that we thought it was going to be, it's actually really wasn't a great fit for. And it's actually a better fit for, there's more adoption or more openness from the enterprise world. But it's really hard to change your MRD like that. It's so hard to go from like, oh, we're building a lifestyle product to now it's an enterprise product, because all the trade-offs that you're making from a product design standpoint, they don't always translate. So that's why in the enterprise scenario, you had people attaching battery packs and having heat sinks and all of that kind of stuff. Subsequently, Glass has, since I've left, they've redesigned Google Glass to be more in line with kind of the enterprise world. But at the time, it really wasn't the right fit. And there are good examples of products that do this well, like iPad, for example, that they never designed it to be an enterprise product, but like it's a great consumer product and just happens to be used like by pilots, for example, in cockpits. But it's hard to do that with kind of wearables. And I think that there were some things that translated, like comfort and weight and all of that, but battery life and thermals and stuff, it's just such a hard thing to do, to change kind of your customer base like that later on in the development cycle. And I think that's really where we ran into a lot of problems.